1. Our Rube Goldberg project exhibits the Newton's 3 laws. The first law is an object in motion will stay in motion unless acted upon by an external force, and an object at rest will stay at rest unless acted upon by an external force. Newton's second law is force equals mass times acceleration. And the third law is every action has an equal and opposite reaction.
Our project also reflects the conservation of energy and the conservation of momentum. The conservation of energy is a principle stating that energy cannot be created or destroyed, but can be altered from one form to another. And the conservation of momentum is a general law that explains that total momentum in a system remains constant.
The first transition, we see the concept of conservation of energy. When the car goes from being stationary to rolling down the track, it converts potential energy into kinetic energy.
In the next transition, we see the car then go through a loop, and this represents the conversion of energy as energy is transformed between potential and kinetic.
Next, we have conservation of momentum. When the car flies off the track, it hits marbles which bump into each other, then forcing one marble into the marble track.
The marble falling down the track is Newton's second law of motion because it picks up force the faster it moves, and its mass contributes to the force it will continue with into the cup.
The marble falling into the cup is an example of Newton's second law, force equals mass times acceleration. As the marble falls into the cup, its mass and gravity acting against it work to create a force that moves the next object.
The cup is attached to a pulley system with a roll of tape attached to the other end. As the cup is weighed down by marbles, the roll of tape is lifted upwards.
The tape was blocking a train on a sloped track, so when the tape is lifted up out of the way, the train rolls off the track. The string was wrapped around the train and attached to a piece of paper at the other end. This is an example of Newton's second law because the mass and acceleration of the train to the ground creates a force that pulls the piece of paper out from under the book.
When the book falls, we see an example of Newton's third law, which is every action has an equal and opposite reaction. When the book falls, it dominoes into another.
When the last book falls, we have an example of Newton's first law of motion, which is an object will stay at rest unless acted upon by an external force, and an object in motion will stay in motion until acted upon by an external force. The book hits a stationary ball and it rolls down a tube.
Once the ball exits the tube, it rebounds off a stationary textbook and is directed down a slope where it will knock over an open water bottle into the plant. This interaction shows us conservation of momentum since the moving ball transferred its momentum into the stationary water bottle. This exceeds our goal as it then waters the plant.